Welcome back to Ask a Creationist. I'm Todd Wood. I'm a young age creationist, and I'm here to answer your questions about evolution, origins, creation, Genesis, the Bible, science, faith, whatever you got. We're interested in hearing from you, so let us know if you've got a question about creation. This episode, we are continuing our series, Is There Evidence Against Evolution? Or as I like to think of it, is there evidence inconsistent with or poorly explained by evolution? And I've tried to explain this before. There's basically rumors going around that I think all science is perfectly consistent with evolution and that there's no problem whatsoever, or no anomalies and anything like that, and I think that's rubbish. So time to correct that. So this is part 8 of a series, so you should go listen to it from the beginning. And this time, we have to deal with the question I've kind of been avoiding: what about adaptation? Which is a central feature of Darwin's Origin of Species. It is central to his notion of a mechanism. And so what about adaptation? This has been a long-standing thing in creationist circles. You might recognize this guy. That's William Paley. He wrote the book Natural Theology, which was a wild, gigantic bestseller, which basically looked at various adaptations in organisms and claimed that they were evidence of the attributes and existence of the deity, as it says there. And so he would say, if you wandered out onto a field and you found a watch and you saw all the parts working together to tell time, you would know that there was a watchmaker. And so too, when you see all these wonderful parts working together in an organism, you know that there's a creator. That's the basic argument. And this argument is essentially still around in the modern world. Mike Behe's mousetrap analogy, the notion of irreducible complexity, and various examples that he gives, like here the bacterial flagellum is what he would consider to be irreducibly complex and not explainable by evolution. And so it must evidence, therefore, an intentional designer behind living things. Okay, so what about adaptation? And as I said, I've kind of been avoiding this. It's an interesting thing, and it's sort of like, to me, this sort of endless stream of argumentation about the details and minutiae of things that I'm just not that wild about, honestly. So for me, thinking through this, I have to admit that natural selection certainly sounds plausible. Natural selection in the sense of traits that provide an adaptive advantage to organisms such that they leave more offspring should spread through a population, and then in future generations perhaps even become fixed in a population. And so over eons, therefore, you can imagine organisms changing form somewhat dramatically. And not organisms, I should say, but populations, so that the descendants look quite different from their ancestors. On the other hand, I also note that there's a lot of amazing complexity and a lot of amazing organisms. And superficially, I would have to agree with Mike Behe and a lot of the ID people that there are things out there that are just really, really hard to imagine how they could have evolved by natural selection. But can I really be certain of that? Is this something that I want to really bank on, right? That there's just no way that natural selection can explain an attribute. So that leads me to wonder about, are there other complexities that might be difficult to explain or to account for by natural selection? And honestly, I think there is. And let me tell you what I think it is. It's altruism. Altruism, or in some sense, eusociality, this notion of organisms that are working together for the common good, and evidenced here by the classic example of the honeybee hive. So biologically speaking, altruism is a behavior that provides a benefit to some individual at the expense of the individual doing the behavior. In evolutionary terms, we would emphasize here the notion of fitness, right? Reproductive output. So essentially it is giving up reproductive output for the sake of someone else's reproductive output. So in the beehive, you've got one queen bee that produces all the offspring of the hive. You've got a few male drones that fertilize the queen. And by a few, I'm talking maybe as many as a couple hundred, but not much more than that. And then the bulk of the hive, tens of thousands of bees, are female workers that don't actually reproduce. They do essentially all the work. They care for the young, they provide food for the hive, they defend the hive, they build the hive, but they don't actually reproduce. So essentially you've gotten a culture here where, or a society here, where the vast majority, 99.9% of the individuals in this hive have given up all of their reproductive output for a single female and maybe 100 or so males, which that's a staggering thing, right? And you might wonder, well, why would they do that? And remember, we got to think of this in terms of, how does this evolve? By natural selection. Because, of course, natural selection, sort of on the face of it, favors any adaptation that increases the individual reproductive output, right? So where do you get this hive, if you want to call it a superorganism, where tens of thousands of individual organisms have given up their reproductive output completely for the sake of one female, one queen? And I want to emphasize here, there's an answer for that, and that answer is kin selection. There's a lot to kin selection. I don't want to minimize it here, but the basic idea is that you don't give up your reproductive output for just anyone. You will work together and give up some of your reproductive output for the sake of close relatives who actually share your genes. So the idea here is that selection does not always work at the level of the individual organism, but sometimes it works at the level of, say, the beehive, right? So if your beehive is better at producing offspring than some other beehive, then your beehive, the structure of your beehive will become greater and produce more offspring for the next generation and so forth. I admit this is a very powerful way to analyze altruism. In fact, a number of examples come to my mind besides just the beehive, and it's the close relationship of the individuals in the beehive. But I can also think of scrub jays and the way they protect nests of their parents. Young scrub jays, after they've fledged and are reproductively mature, will stick around for a year and basically protect the nest of their parents as the parents raise the scrub jay's sibling. But at the same time, it's a long way. Kin selection as a way of analyzing altruism is great and useful, but it's a long way from explaining where it comes from. So think about this in terms of going from a culture of selfish individuals that only look out for their own reproductive output to essentially this society that is built around one individual's reproductive output. So think of it this way. Let's say you actually have, and we're going to start this backwards a little bit, but let's say you have a culture of altruists where everybody does not just look out for their own needs, but they look out for the needs of other people. And they are willing to go out of their way in order to benefit other people. And if every individual, therefore, has a certain reproductive output, then it makes sense that collectively, these individuals who are willing to give sacrificially to other people, those individuals are, in fact, that culture is going to be extremely good at producing young and producing offspring. Just because everybody is looking out for everybody else, right? So you don't just have to take care of you and yours, you and your offspring. You've got other people looking out for your back. Now that works great so long as you don't have a selfish individual, right? One selfish individual comes along and says, if I just take and don't contribute, then I get to reap all the benefits of living in an altruistic culture. But I get to reap even more because I'm not going to go out of my way to help anybody else. And over the generations, if that one selfish individual infects that altruistic culture, that selfish individual is going to spread, of course. And eventually the whole culture will become selfish. It's sort of inevitable by the rules of selection, because I can maximize my reproductive output by expending all my energy only on reproductive output and not on helping somebody else's reproductive output. See how that goes? So this raises the question of, how do you get the altruistic culture in the first place, right? How do you go from all selfish to a thing like a beehive, which is nearly perfectly, it's probably the most complex altruistic culture you can imagine in biology. It's a mystery. It's peculiar. It's strange. It shouldn't work. And it's not just because it's super complex and it can't be explained by, slow and gradual processes. It's literally that the rules of selection work against producing something like this. So yeah, I think altruism really is the big open question in selection studies and evolutionary biology. Hey, if you've enjoyed this video, please leave a like. If you enjoyed it even more, subscribe. If you liked it even more than that, click that bell icon to get notifications for our next episode. If you dislike this video, leave a dislike. That's fine too. I just love interaction and attention, so shower it upon me. Please visit coursei.org. There you'll find links to our social media accounts. We're on Instagram, Twitter, and Facebook. You'll also find links to support us financially, and we would very much appreciate that and appreciate your support. Also, check out our new podcast, Let's Talk Creation, with Todd and Paul, me and Paul Garner. We're doing a podcast now, and it's kind of like this series here, but bigger and more interesting because there are more people than just me talking. So you might like that. Thanks for watching. See you next episode.